All right, let's greet each other properly. Good morning. This is Mr. Ainsworth, and we're going to get into our second lesson on how to solve quadratics here and talk about how to solve quadratics by factoring. So let's write our goal down first. We want to be able to solve quadratic equations by factoring. So quadratic, which is second degree equations, quadratic, second degree, all right, equations by factoring. All right, that's our first technique in this unit that we want to explore. All right, be factoring. There's many different techniques that we're going to explore. In fact, you know what? Let's go back to the beginning in the assignment sheet and just take a peek at the different methods, okay? We are going to explore how to solve quadratics by factoring, by square roots, completing the square, and by the quadratic formula. So we want to hit all those techniques throughout the unit here and solve all different types so that when we get to the second half of the unit, when we talk about quadratic families, okay, with the parabolas that you studied before and graphing them, we can handle all the different aspects of it. All right, so let's get right into it here. Let's go back to our lesson, our how to solve quadratics by factoring, and let's review first uh, the factoring techniques that we explored in the prior unit, okay, when we talked about how to factor polynomials, okay. Now this first one here, I noticed that they have a GCF in common. I see that they have a 3 in common, they have an x in common, okay? So what we're going to do is we're going to factor out the GCF. Whenever you see there's a common factor, factor it out. So write down factor out GCF. That's the very first thing we do in all polynomials when we see or when we're asked to factor. Okay, so here we go. We have 3x here times, let me see, this is 3x times x minus 3x, 3x times 4. So what I just did there is I factored the monomials here. All right, I noticed they have 3x in common, so I factor that out. Well, you got to multiply it by the remaining factors, and we're talking about x minus 4 here. 3x times x is 3x squared, minus 3x times 4 gives us the 12x. I just factored out the common factor of 3x. Now there's nothing in common in the second one, so we got to play that little game here. Negative 6 times 1 here, so let's play this little game. Negative 6 times 1 is negative 6. They add to negative 1. All right. So what two numbers multiply to negative 6 and add to negative 1? Well, I can see that it's negative 3 times 2 because negative 3 times 2 is negative 6 and negative 3 plus 2 is negative 1. All right, so what we're going to do is we're going to split the middle term like we always do and factor by grouping. So we're going to have x squared minus 3x plus 2x and then bring over the minus 6. All right, just split the middle term right here. So the negative 3x plus 2x is just a negative x. Didn't do anything fancy, and I didn't play God. I just rewrote the middle term. Now I factor out the GCF just like I did in number 1. So this is going to be equal to x times x minus 3 plus, I see a 2 in common here, so factor it out. Now I see a x minus 3 in common, so I factor out the common binomial and multiply it by the remaining factors. You see this x minus 3 right here? I have to multiply it by the remaining factors, the x plus 2, that goes here, times, okay, x plus 2. Excuse me, I gotta put the right number in there. There we go. All right, now the second one, or the third one here, same type of thing. I want to multiply the 6 times negative 5, so negative 30. All right, so what two numbers multiply negative 30 and add negative 13? All right, well, that should be pretty obvious. Negative 3 times 10, or negative 3 times 10 is 30, right? So I'll put 3 times 10 here. 3 times 10 is 30. I want negative. Oh, you know what? I'm going to have to change this right here. I'm going to have to, everybody, this is a typo here. Let's make this positive, positive 30. Okay, what two numbers multiply to 30 and add to a negative 13? Well, how about negative 3 times negative 10? Okay, they multiply to 30 and they add to a bigger negative, negative 13. Change this, okay? Fix it. That was a typo. All right, so let's split the middle term. So we have 6x squared, all right, minus 3x minus 10x, and then plus 5. Factor out the GCF of 3x squared. See, 3x times, oh, that's not correct. Let me fix that. 3x times 2x is a 6x squared. So 2x here minus 1, okay? Because 3x times 1 is 3x here. I'm going to factor out a negative 5 because this term is negative, and I get 2x here. 5 times 2x is negative 10x. And then times 1. Nope, minus 1. Change that. Minus 1 here. A negative 5 times a negative 1 is positive 5. There we go. Now the binomials are the same, so factor it out. So we have 2x minus 1 times the remaining terms, 3x minus 5. There we go. All right, so that's what we did last unit on factoring. Now let's apply everything here. What we want to do is take a quadratic in standard form here and solve it. Now standard form looks like this. Ax squared, all right, plus bx plus some constant here equals 0. Okay, the right-hand side is 0. Let's make note of that. The right-hand side, all right, is equal to 0. Okay, let's highlight that. There we go. Right-hand side is 0. Make sure you know that. A, B, and C are called coefficients. All right, so this is called a coefficient. These are called coefficients. Coefficient. Crazy word here. Coefficients. All right, and C is a constant. This right here is just a constant term. You'll see that in a minute. Well, I'll show you in a minute when we get down there after a few examples, okay? So, how do we solve these quadratic equations by factoring? Well, what we need is what's called the zero product rule. And it states that for any real numbers m and n, if you have a product equal to 0, m times n, something times something equals 0, this is true if and only if one of them is equal to 0. So let's put either m has to be equal to 0, this first factor, these are called factors, let's write that down. One of these has to be 0, and, or, okay, not and, okay, let's put or. N equals 0, okay, or both, okay? They may both be equal to 0. We know that anything times 0 is 0, and that's why this is true. Either the first factor has to be 0 or the second factor has to be 0 for the product to be equal to 0. Why? Because anything times 0 is 0. You got to know that, all right? So if you have a product equal to 0, which is called a zero product, well, one of those has to be 0 for that to be true. Now, here's a little important note. The quadratic equation must be set equal, all right, to 0. This is a zero product rule, okay? Not another product rule, but what's called a zero product. So this has to be equal to 0, not negative 1, not 2, not any other number, but 0, okay? It's got to be in standard form. That's an important note. All right, let's get right into it. It's not that hard. We're going to apply the zero product rule and solve all the quadratics, all right, in this entire lesson. All right, so the first thing we do, let's put the steps over here on the left-hand side in the margin, as we always do here, is you want to make sure that your quadratic is in standard form. All right, set equal to 0, okay, and that's called standard form. All right, I can see that it's equal to 12x here and not set equal to 0, so I can't use the zero product rule right now. All right, so what we have to do is we have to take your quadratic equation, whatever it may be, all right, and set equal to 0 first. Otherwise, I can't use the zero product rule because I said the quadratic equation must be set equal to 0. So that's easy. We subtract 12x on both sides and make the right-hand side equal to 0. So when we do that, we got 0 here. We got 3x squared minus 12x. 3x squared minus 12x. Those are not like terms, so you can't combine them. And this right here, the right-hand side, is equal to 0 now. All right, and when we do that, we factor out the GCF. We factor it into a factored form, a product. All right, so step 2 is factor. Let's write that down. Factor, and there's different types of factoring, but the general step is to factor into a product. All right, factor. So what we do is what we did in the beginning here, and we factor out the GCF of 3x. So 3x times x minus 4 equals 0. And now we have a zero product. Why is that? Well, we have something times something equals 0. It looks exactly like this right here in this form. So what we had was we had the first factor and we have the second factor, and one of those has to be equal to 0. So step 2, or 3, excuse me, I want to set each factor equal to 0. Each factor equal to 0, okay? And step 4 would be to solve each equation. Solve each equation. So let's do that. I'm going to take them over here where I have a little bit more room. I have my first factor 3x. Well, that could be equal to 0. Draw a vertical line to separate the two equations. And I got my second factor, x minus 4, equal to 0 as well. You solve each of those equations and you get your two results. A quadratic equation can have up until a maximum of 2 solutions, okay? Either 0, 1, or 2 solutions because of a second degree. The degree always tells you the number of solutions of the polynomial equation. All right, so in this one here, 3 times what is 0? Well, it's got to be 0, right? But if you want to solve it, it looks like this. X equals 0 here. That should make sense because 3 times 0 is 0. Here, 4 minus 4 is 0, so the answer better be 4. But if you want to solve it, just go ahead and do so. And you get answer 0 and 4. And there we go. So x can be 0 or x can be 4. You get 2 solutions. Let's write that down. 2 solutions to the equation. All right, and you got to be happy because, hey, man, you just did it. It's a 4-step procedure for all these guys. All right, the first thing is if you need to set it equal to 0, go ahead and do so. Do whatever is necessary. Add the opposite and set that baby equal to 0. Step 2, we factor into a product, okay, into something times something equals 0. Step 3, we set each factor equal to 0, like we did here. And here we write 2 equations down. And that's pretty straightforward. And then use your basic arithmetic and solve each one. So let's get some practice. Now this is a video. So if you're watching here at home or at school or whatever, go ahead and use the pause and play feature and pause it and work through the example. And then when you're ready, press play. All right. So let's take this off to the side. I want you to pause the video right now. All right. Factor out the GCF. All right, because this one's already set equal to 0, so there's no need to do step 1 because it's already done for you. Nice. Okay, pause the video and go. All right, so let's factor out a 2x here. I got x plus 12, excuse me. All right, 2 times 12 is 24. So that's equal to 0. I set each one equal to 0. So 2x could be equal to 0, or the x plus 12 could be equal to 0. All right, divide by 2, and you get x equals 0 here, because 2 times 0 is 0. Subtract the 12, and you get x equals negative 12. There we go. And that's the first one there, or the second one, excuse me. All right, pause the video and give the next one a shot. All right, on this one here, finding the GCF of 3/8 and 9, it might be a little bit difficult. So let's just factor out an x. So x times 3/8 x is the first term, minus x times 9 gives you the second term. So I just factor out a variable. That's possible too. All right, and we got a 0 product here. All right, we got something times something equals 0. So this x can be 0, because 0 times anything is 0, so that could be the case. Or 3/8 minus x, or excuse me, 3/8 x minus 9 could be equal to 0. I'm going to solve that. Well, let's add 9. And we have 3/8 x equals 9. I'm going to take it up here so we can have some more room. 3/8 x equals 9. I'm going to multiply by the reciprocal. So times 8/3 times 8/3. This is called multiplying by the reciprocal. You guys have saw me do that a long time ago in our equation solving. This is 1. So you get x is equal to, let me see, 3 into 9 is 3 times 8, 24. So I have 2 solutions there, okay? I have x equals 0 and x equals 24. Again, you're looking for 2 solutions on these quadratics, okay? Because you're going to split it into 2 factors. Each one has a solution. All right, let's try other cases. Now on the number 4, this is a trinomial, and look at this, it's not equal to 0, okay? You have to set equal to 0 first before you even do anything. This is equal to 0 right here, set equal to 0. So what do? Well, you just subtract 15, all right? So that's your first step. So go ahead and pause the video, make your first step. All right, so let's subtract 15. We get x squared minus 2x minus 15 equals 0. Now we got to play this little game right now. So what two numbers multiply to negative 15 and add to negative 2? And they're negative 5 times 3. So negative 5 times 3 is negative 15. Negative 5 plus 3 is negative 2, so we're good to go there. Now I need to factor it. So x squared, let's split the middle term here, minus 5x plus 3x minus 15 equals 0. Factor out the GCF. Just do what we always do. All right, factor out the x minus 5, and you have a 0 product. All right, so now one of these has to be 0, right? So what would make the first binomial equal to 0? And then what would make that second binomial equal to 0? And just by looking at it, I could tell it's going to be 5 and negative 3. Those are going to be my results. But once again, you set each factor equal to 0. This is your first factor, and this is your second factor. Okay, so here we go. We got x minus 5 equal to 0, and my second one, x plus 3 equal to 0. Well, add 5, and you get x equals 5, and you subtract 3, and you get x equals negative 3. Those are my two results, okay? Number 5 is the same. So if you're watching that, go ahead and pause the video now and try number 5. All right, so let's try it. X squared plus 7x is equal to 18. So subtract 18. Got to set it equal to 0, right? So x squared plus 7x minus 18 equals 0. So I got to play this little game here. What two numbers multiply to negative 18 and add to 7? Well, let me see. I know that 2 times 9 is 18, but one of them has to be negative. I want a positive 7, so let's make the smaller one negative. The bigger one positive here. 9 minus 2 is positive 7. So if you want a positive 7 here, the bigger number has to be positive. All right, let's factor using these right here. So minus 2x plus 9x minus 18. Factor by grouping. Factor out the GCF. All right, factor out the x minus 2 because that's in common, and multiply it by x plus 9. And I can already see in my factored form here, I got a 0 product right now. We got something times something equals 0. Well, what would make this first binomial equal to 0? Well, the answer is obviously 2, because 2 minus 2 is 0. So I got one solution there. The second one, negative 9 plus 9 is 0. So I know my answers have got to be 2 and negative 9. But if you don't see it, let's just go ahead and write it down, okay? X minus 2 could be 0, or the x plus 9 could be 0. On the first one, add 2, and the second one, subtract 9. And you can see exactly what I just said. 2, positive 2, and negative 9 are my solutions. If I substitute 2 in here, I get a 0. 0 times something is 0. And if I put a negative 9 in, negative 9 plus 9 is 0, and I get a 0 product there too. On all of these, after you factor into two binomials, you're going to be getting two solutions. You just set each binomial equal to 0, or each factor equal to 0, and solve. All right, you can do it mentally just by looking at it, or you can set it up and set both equal to 0 and solve. All right, now the next one's a little bit more challenging because we have a coefficient here. So let's go for it. So let's, you can pause the video here and try it, and then now when you're ready, go ahead and press play. So let's check your work here. We've got subtract 5. You got to make this polynomial equal to 0. So 24x squared plus 14x minus 5 equals 0, and we got to play the game again. All right, so what two numbers multiply to negative 5 times 20? 4. Okay, so 24 times 5 is 120, right? But it's negative. So negative 120 here. And then what two numbers multiply to that and add to 14? Well, I know that just by inspection, the factors of 12 are 6 and 2, but this is 120. So 6 times 20 I know is 120. 20 minus 6 is 14, so we're looking good there. Make this one negative. 20 minus 6 is 14, and negative 6 times 20 is negative 120. So we're good to go. All right, so let's split the middle term here. So 24x squared minus 6x plus 20x minus 5 equals 0. Factor out GCF of 6x. So we got 4x minus 1. Factor out of 5. So 5 times 4x minus 1 equals 0. So we have 4x minus 1 times my remaining factors, 6x plus 5. All right, now from here, you set each one equal to 0. So let's do that. 4x minus 1 equals 0. Draw the vertical line, and then you have 6x plus 5 equals 0. All right, add 1. You get 4x equals 1. Divide by 4. You get x equals 1/4. On the second one, you got to subtract 5. And you get 6x equals negative 5. Divide by 6, and we get x equals negative 5/6. And those are my two solutions, 1/4 and negative 5/6. It's a little bit more challenging because the lead coefficient right here, this 24 here, makes it a little bit more challenging on the factoring, and it changes the solutions, all right, to not being integers but being fractions. Now the next one's the same, so pause the video, give it a shot. Okay, now let's check your work here. It's already set equal to 0, so the only thing you need to do is play the game again. So what two numbers multiply to negative 24? All right, negative 8 times 3 is negative 24, and add to negative 10. So let me see, 2 and 2 times 12 is 24, but I need it negative. So one of these has to be negative, and I need a negative 10 when I add them. So let's make the bigger number negative. 2 plus negative 12 is negative 10. 2 times negative 12 is negative 24. All right, so let's split the middle term. So 3x squared plus 2x minus 12x, just looking at these factors right here, minus 8 equals 0. It doesn't matter the order here. You could have written it as 3x squared minus 12x, okay? In fact, it probably would have been better that way. So factor out x out of the first group, and you get 3x plus 2. Factor out a negative 4 on the second group. And they're both negative, and they're both divisible by 4. So you get 3x plus 2 again. And remember, these binomials are always going to be the same in the factoring. Distribute back through to check, all right? Keep on factoring here. Factor out the 3x plus 2, multiply it by the remaining factors, x minus 4, and you got a 0 product now. Now from here, we set each one equal to 0. So 3x plus 2 equals 0. Draw the vertical line to separate the equations and stay organized. Subtract 2, you get 3x equals negative 2, divide by 3, and you get x equals negative 2/3. On the next one, the second one's easy, all right? 4 minus 4 is 0, so my answer is 4. And I get two solutions there, negative 2/3 and 4. All right, and only one more to do. All right, so the next one, right here, pause the video and get started. All right, so in the next one here, we want to subtract 7 and get it in standard form. So we have 6x squared minus 19x minus 7 equals 0. And we got to play this game again. So 6 times negative 7 is negative 42. And what two numbers multiply negative 42 and add to negative 19? So let me see. 6 times 7, if I put a 6 times 7 here, I don't even have a chance. 6 plus 7 is 13. So bad choice there. 2, what's 42 divided by 2? 42 divided by 2, 21. All right, so try 2 times 21. So 2 times 21, one of these has to be negative. Now I need a negative 19, so let's make the bigger one negative. 2 plus negative 21 is negative 19, and there we go. So split the middle term. All right, just like we always do in the factor by grouping. All right, factor out a 2x here, and you get 3x plus 1. Factor out a negative 7 here, so 3x plus 1 again. Distribute back through to check, it looks good. Distribute out the 3x plus 1 because that's in common. Multiply it by the 2x minus 7. Those are the remaining terms. And here we have 3x plus 1. Well, that could be equal to 0. Or the 2x minus 7, that could be equal to 0. You set each factor equal to 0 and you solve each separately. You get 3x equals negative 1. Divide by 3 and you get x equals negative 1/3. Here add 7 and you get 2x equals 7. Divide by 2 and you get x equals 7/2. All right. Now I know this is went up probably a little bit too fast. All right, but you guys got to remember that this is a video. All right, and what you have the opportunity to go back and rewind and listen to it again. Give it your best shot and use the video to your advantage. Pause, play, rewind, and go back, forth, and try it and practice it. All right, that's the key. Is a lot of good practice. In fact, speaking of that, that's why you have some classwork, homework. Okay, so turn on the back side here. You've got plenty of room to solve the following by factoring. All right, so solve by factoring. That's the key. Just underline the word factoring. All right, so give it your best shot and check it with my solutions, and I'll see you in my next lesson. This is Mr. Ains. We're signing off. I'll see you then. Bye-bye.